Okay. Now let's continue this in the form of problems. Okay. So remember this term LCA? We discussed this in trees. Who remember this?
Least
Common
lowest
ancestor.
common ancestor.
Exactly. Its lowest common ancestor, right? So, uh, okay, let's draw a normal tree probably. Okay, and let's see. Now, let's say this is U, this is V. Can I say the LCA is this?
Yes.
Okay, and let's say this is U, this is V. Can I say that what is the LCA in this case?
V.
V, right? So probably like you guys know what is LCA. Okay,
Yeah.
okay. Now let's say again the same problem comes that given a tree, given two nodes to you, you need to find out LCA. What will you do in that case? Let's start with brute force. So I want uh, someone to come ahead and explain the perfect brute force to me. Will you come or shall I call one? Wanna give it a try, Sam?
Yeah. You and we are given, right?
Yes.
Yes.
Let's say this is U and this is V.
Okay.
Yep. Yeah. Are you saying?
Not getting the idea.
Okay. Deva.
None, nothing, bro.
So we can do a DFS from one of the node.
Mm-hmm.
Uh, we can check whether it is we are getting these two nodes or not, U and V.
Okay. So from okay, let's say I'm doing DFS from here,
Yeah.
and then what we will do?
Uh, so if the DFS consists of U node and also V node,
This is a tree, right? Trees means every time it will visit every node, no? Tree has that property that it's a single connected component. So,
yeah, yeah, okay, yeah,
okay. So let's say, do you guys remember we maintained a parent property?
mm-hmm.
In DFS, we maintained depth, we maintained parent, everything.
Yeah.
Yes,
So if I
Yeah.
do a, if I take any random node and make it a root of the tree, okay, and let's say after construction of the parent of every node, let's say this is U. From parent, I will go to root node, which is nothing but U. Let's say this node is A. Let's say this node is B. So can I create a list having this UAB? I mean, go from here to top unless you reach root. Can I store
yeah,
this?
yes,
Yeah.
yes,
Similarly,
yes,
can I store here also? Let's say V X Y A B.
yes,
After this, it's all about what is the last node which is common in them. Isn't
yeah,
it the
correct,
problem?
yes,
Yes.
So let's start from point two pointers from here. BB same, AA same, U and Y are not same. If they are not same, we know that A is the answer because this is the last node which is being visited. And in fact, if you see the diagram, A is the one which is the LCA of U comma V. Okay. So this does solve our problem, but there is this caveat of again what we are doing. We have to go from node to the root, from root node to the root, and then do a linear search, right? Which is again a time taking process. So how can we solve this problem efficiently using the technique which we just learned? Okay, so let's see. Okay, how can we do this problem? So there are a couple of steps which we need to follow, and probably like you'll understand. I mean, these are very intuitive. It's actually easy to understand. Okay, so where is u? Here is u. Where is v? First task. The task is uh, bring whoever is having a more depth, bring to the same depth wherever you have the smaller path. Okay, so in this case u is at depth 2, v is at depth 4, right? Depth 0, depth 1, depth 2, 3, depth 4. So the first task is bring the node to the same depth wherever you have the lesser depth node. Okay, so in this case, go here, go here. Is the first step clear?
Yeah.
It should be intuitive, right? Because if we have at the same level, then it's much easier for us. Correct? True. Do you agree on that point?
Yeah.
Yes.
Right. So what we will do is we will go to the depth which is having, which is having the lower level. Okay. So once we reached here, it's all about doing a check. I mean, uh, like you have to go to the top. Okay, unless you have to go till the point wherever you don't have the same nodes. Okay, okay, let me show you with an example maybe. Okay, that example is not good because we reached here, right? And the next node itself is a LCA. So let's take a different example maybe. Okay, okay, now we are here.
Same again.
How can I draw a weird tree? Now, Sam. Okay,
I think better you draw child for above node, above that one.
which one? This one?
F- above that one.
This one?
Yes, yes.
Okay. Mhm. Yeah, this makes sense right now. Yeah, this is good.
Yes.
Chalo, let's say V was here initially, okay, and we brought it to the same level where U was, okay. That was the first point.
Correct.
Now, it's
Mm.
about what you need to do. You need to jump to a position where they are not equal, okay. So what we will do is we will actually do kind of binary lifting only, and we will try to find out what's the maximum distance where we can go such that they are not meeting together. They are not meeting together. Okay, so in our case, let's say we try to jump of a distance 4. Can you see distance 4 is outside the zone?
Yes.
1, 2, 3, and 4. So distance 4 is not possible. What about distance 2? If I go from here to here, if I go from here to here, this is the node. And from here also, if I take 2 steps, are we meeting at the same place?
Yes.
Yes.
So this is wrong. I mean, in fact, we should, the claim, whatever I have done just now, was that you should go to a higher position such that they should not meet at the same place. Okay, so 2 jumps is a wrong claim for us. Okay, now can we jump 1 from here? If I can jump a 1
Yes.
distance, I am going here. If I am jumping a 1 distance, I am going here. Now, is this a valid jump, guys? It's a valid
Mm.
jump, right? Because they are not at the same location. Correct?
Yes.
So
Yeah.
once you reach here, your answer is done. It's only about getting the parent of this. It's only about getting the parent of this. So you need to stop the process as soon as you reach it here. Okay. So I understand it's little confusing. The reason why,
Here means like what is that level? Like how to tell where it?
Bro, if there are one more child, then
where
In between.
there only.
here,
हाँ हाँ हाँ. If you have one more child,
if I
नहीं नहीं उसके ऊपर ही.
Ancestor is telling in
हाँ
between. Yes, yes.
here,
In between those two
In
arrows,
between.
suppose
I don't understand. Where is in
अरे
between?
between
just
second and
above.
third,
हाँ
second and third, if there
Yeah,
is another ancestor, yes.
हाँ, one more.
Okay.
yeah. So let's say in this case, guys, are they in the same level, first of all?
No.
No. So the claim was we need to bring to the same level, right? First thing. So unless they are at the same level, you cannot do the second step. Okay. In this case, if you see, there was 1, 2, 3, 4, but here it is 1, 2, 3 only. So are they on the same level? It is on the level 4, it is on the level 3, which is wrong.
Hmm.
So you need to bring it here first. Then only you should start the process.
Hmm.
Bro, if we have like even right has the same number of child. I mean,
Okay, let me tell me and I will draw it. Okay.
yeah,
So shall I draw here one node?
yes, yes, yes,
Shall I draw one more from here?
yes,
Shall I draw one more or
yes.
okay?
Yeah, it's enough.
Hmm. Let's keep a number.
No, I guess like one more thing we need, right? So, five also make it five.
Should I make it 5 from here?
Yes.
Okay.
SAS, like you
Can you
mean
go? Can you go to top diagram, bro?
Okay.
Yeah, in between two nodes, two are required. So four are enough, bro.
Okay.
Mm.
Yeah. From where should
So
I begin?
from right, sorry, from one node, first node,
Hmm.
right.
Okay.
Yeah. Again one more. Yeah, again one more.
Uh-huh.
So after first step, we will be getting this one, right?
Exactly. They are at the same level now.
Correct, correct.
Now, what we will do is
Mm.
first let's try to jump maybe 4 jumps. Okay. So somehow
Okay,
4 jumps are out of the bound and they will reach at the same
correct,
position only. Correct. So
correct,
this is not
correct,
a valid. But if you do
correct.
2 jump, it is valid because they are not at the same location. Correct. They are not at the same location. Right.
Oh,
So
okay, okay.
this is the position where your process ends because from here you know that if you even jump here, I mean we will write that in code, but can you at least
Mhm.
see visually that this is the
Yeah, yeah,
position
yes.
where we end it because
Yes.
this is the LCA. माना
Hmm.
समझ आ गया अभी क्या सीन है?
हाँ हाँ, like previous example समझ आया.
Yeah.
Yeah.
Okay.
bro? If
So
between one and
every time will it work, bro?
It will work. Let's see in the code why it will not work. Okay.
Okay, okay.
Chalo. So shall we start?
Yeah, Sampath is asking something.
like between one and two, we are if we are having one more child, one more node, sorry, and one and five, if we have one more,
Okay.
like we can't take now parents, right? Parents of two and five as a
So
common.
see Sam, from here, let's say first we started with jump 4. Okay.
Yeah.
Mhm.
So jump 4 is this, correct?
Correct.
They are at the reaching at the same location. So this is not a valid jump.
Valid. Mm.
Yes.
From here, we have to go 2 steps.
Two. Mm.
This is valid. Now from
Hmm.
here also we can go 1 step right because still they are not at the same location.
Okay. Okay. Okay.
Okay, and we will
Okay.
see
Okay.
that how
Yeah.
because we will write
Yes.
a
Yes.
loop and we'll make sure that we are doing it.
Okay. Okay. Understood. Understood, bro.
Okay, Deva, do you understand?
Yeah, bro.
Sure.
Yeah, yeah.
Okay, guys, chalo then. So yeah, it would take some time to write the code. So be ready. ये सब क्या बोल रही? New. What's this?
So first jump जो रहेगा that will be depth of the tree, है ना?
Depth
और
of the
फिर
tree. अरे वही देखो
नहीं
गलत बोल दी. Depth of the tree हुई क्या है?
नहीं
फर्स्ट जंप देखो जिसका भी सोचो इधर इधर है ये इधर है सेकेंड नोड इधर है फर्स्ट स्टेप ब्रिंग इट हियर फर्स्ट स्टेप ब्रिंग इट हियर उसके बाद से पूरा चेक
Yes.
करो कहाँ जा सकते हैं, ठीक है. We'll write that in code, that will make more clear actually. LCA dot Java. Okay, and we need lot of things this time. So public class LCA. So what do we need? We need a tree, right? Correct. अरे ट्री तो चाहिए ना, ट्री के बिना कहाँ से होगा.
Yeah.
So do you guys remember how to create construct a tree, or you guys forgot what to do? Hello, am I audible? Hello.
Yes, yes,
Yeah, yeah.
audible, bro.
Yeah, so I was asking, do you guys remember adjacency list? I practice कुछ भी नहीं करेगा अभी.
Yes.
Okay. And so for simplicity we are taking uh, this tree as one based indexing, okay, not zero based, because it will be little easier to handle.
Okay.
Yeah.
Okay. Yeah, wrong.
Bro, adjacency list is similar to directed graph only, right?
Not only directed graph, undirected also, right?
That the only get or add me you are changing. That's it.
Correct.
But in undirected,
Hmm.
Two lines రాస్తాం కదా, get
uh,
you add v, directed లో you remove the second line because you're not matching it.
Correct. So
అదే అదే.
nice. No worries. Next week we have mock. So whatever you guys remember. Okay. So now we will take the input. Okay, I less than
mm,
n minus one. You remember, right? We have n minus one edges in a tree. Right?
yes.
So int u. Now this is one based indexing. Okay. Int v.
Mm,
What we need? Adjacent dot get u dot add v. Manan second line add करना है कि नहीं?
directed ఏనా.
तो add कर देंगे, खत्म. Tree ready. Okay, tree is ready now. Now what we need, so do you guys remember we need to construct a DP table, I comma j something.
yes, yes, yes.
Yes.
So time to create our favorite structure. Okay, static int DP. क्या करेंगे? DP equals to new int of. So see, if can I claim that if there n is up to 10 power 5, the second dimension if I keep till 20, is it's enough for me?
Yes.
Static final int max bits. Okay.
Or ek bar 20.
Sorry.
How we got 20? I didn't get.
So Sam, you are very famous for this, right? You will tell me 10 cube equals to 2 power 10.
Yes, yes.
If 10 power 5 means it will always be
Okay, okay. Yeah.
right?
Okay, okay. Got it.
Okay. Now, what we need? So second thing which we need is we need a DFS, right? So we will start our DFS. So since it's a one based indexing, I am start from one. What else do we need? We also need a depth, which since we don't know, right, which node is at more at the lowest level. So that's the reason we will maintain depth also. And this is what we also learned in trees also, right? Maintaining depth.
Yes.
Okay. So depth equals to new int of n plus 1. So I'm starting a DFS from 1. Obviously for 1 there is no parent, so I'm keeping it as 0 and depth is 0. Okay. Time to create the DFS function. int node, int parent, int d, I mean depth. Okay, so first thing first, let's also handle parent also. Parent of node is nothing but depth of node is nothing but what? Now dp of, yeah, someone tell me this perfectly. What should I write here? 0 means what? 2 power 0,
0.
which is one level up.
Mhm.
So can I write it? Okay, tell me. क्या लिखना है इसमें? Deva, what should I write here? 2 power 0 is what? For 1, right? So what is my immediate?
Parent.
Exactly. ठीक है? Construction of dp table. So for int equals to 1, I less than max bits, I plus plus, dp of node I is nothing but dp of node of I minus 1, comma. Is this okay?
क्या लिख दिया भाई?
He was not there.
Okay, so uh, you should see the recording, Manan. I cannot explain,
Okay.
but the guy
ठीक है.
Formula.
who listened, did you understand this?
Yes, yes.
Yeah, yeah, yeah.
Same.
Deva?
Yeah, yeah.
चलो, तो dp is ready, right? So if dp is ready, what shall we do next? If dfs of pure dfs, so whatever we learned earlier, then
Yeah, yes.
okay, so is this method clear? DFS, normal DFS. Only thing we did is this. So Manan, this is a formula which we derived. Okay, so probably you
Okay, sure.
the recording, but yeah, this is for time being. Remember, this is a formula. Okay, that for
Okay.
node I we can derive it using like this.
Okay.
Okay. The now we have one more task which is static int get LCA. Correct?
Hmm.
What can we do for here? Okay, so what we will do is, so in general, if you see the blogs or whatever, I mean there can be multiple ways to handle it. So how many things will be there? I mean, you can be up, we can be down, you can be down, we can be up, right? Can I say that there are these
Yes.
two possibilities? So how we will handle is, we will always keep you as the bottom, we as the top. Okay.
Okay.
Okay, now I'm writing something. Let me know if you're understanding this. If depth of V is greater than depth of U, swap the variables. Can I say this?
What approach we follow? We keep U up or V up, like we
U,
consider.
U down, Sam. Okay,
Okay, okay.
U
Yeah.
down and V as the top.
Okay.
So
Then
if V and U, I mean if V is more down, we need to interchange the variables. Okay,
yeah.
interchanging means, if this is if this is U and if this is V, what you do is, please make this as U, make this as V,
Changing names. That's all.
changing the names, swap the variables. So someone please tell me how should I write this? Swap the variables.
With the temp or without temp.
Anything, doesn't matter, but it should work.
Int temp is equals to.
Okay, chalo. I thought you will tell the Zor one. Yeah.
U
Okay.
uh,
U
into
equals to
U.
V.
V is equals to temp.
So, guys, does this make sense for everyone? Whoever
Yes.
understood this?
Yeah.
Chalo, theek hai.
Yeah.
Now, we have what we have. We have V here, U here. Correct? Second thing is we need to bring it here, right?
Mm.
So, int difference in depth is nothing but, can I say this? Can I say this?
Yes.
Now the interesting part comes. Okay. Say I am very much down. I mean, I'm at very bottom level. One way to do is go sequentially till here. But will we follow that in today's session?
No.
Will we do this? Will we go sequentially here, or will we do
No.
jumps?
Jumps.
Jumps.
So
Binary left.
so can I say in the question K is nothing but difference in depth,
Mm.
right? So
Yes. Yes.
for int I equals to 19, because 19 is enough. I greater than 0, I minus minus. If bit is set, remember K equals to 6 means 110. So if we used to go to 2 square, then 2 power 1. Correct?
Yes.
So if difference in depth and am I writing correct? I mean,
Yes. Set bit. It
exactly.
means
If this is the case, can I say U equals to dp of, can I say this? Think and let
yeah.
me know.
Going to parent of it, right?
Exactly.
Yes. Yes.
So,
Okay.
Manan, Deva, Sahas, did you understand whatever I just wrote now? Or is there any confusion?
ये previous
No, bro.
recording like previous question से related है. I will
See,
have to see recording फिर.
okay, yeah, yeah. See,
Hmm.
basically, like, let's say if I have to reach here, man, okay,
Hmm.
1, 2, 3, 4. So how many distance? I mean, the distance is 6, right?
Hmm.
So 6 can be written as 110, right?
Yes.
So 2 square, 2 power 1.
2 power.
So if you see, our difference is this is 6. Wherever the bit
Yes.
is set, just go to the parent. Okay. So instead of traveling 6 times, Manan, what we will do is we will go to fourth node, and
Hmm.
from 4 we will go to second node, because 4 plus
Okay.
2 is 6 only, right?
Yes. अच्छा.
So this is what
Okay.
we maintained in DP. Okay.
Hmm.
So, okay. What about Sahas and Deva? Did you understand this? If not,
Yeah.
I I did not understand that 70th line.
this one.
Yeah.
So what is DPUI, Sahas? It's nothing but, let's say if I,
IJ.
yeah. So can I say for this, the fourth node will be this only?
Yes.
So
Yes.
DP of U comma I is this only, right? So my U is here. I need to bring my U here. So from here I will go to this position, and from here I will go to this position. Now did you understand, or shall I repeat again?
Okay. Yeah. Understood. Understood.
Okay, right? Sure.
Yeah. 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 Yes. Understood.
Okay. At this position, can we claim they are on the same level?
Yes.
Correct? So remember this one single line which we have to write every time. Don't forget this. Okay? Sometimes if we don't write this, will give a wrong answer. after coming to the same level, if they are standing at the same position, can I say the LCA is nothing but U or V, anything?
Yeah.
Correct? If they are at the same position, that means
Yes.
the LCA is this only, right? Okay. So this is what we have. Now the next part is jump till a position where they are not same. So for same thing, okay, what we will try is if dp of u comma I is not equals to dp of v comma I, u equals to dp of u comma I, v equals to, now is this for loop clear, or do you think I need to explain it? So remember the point when we are at the same level, what we tried jumping to a level where they are not same, right? Correct?
Yeah.
Yes.
That's the reason we will start from the highest position. Okay.
Okay.
And what is u comma I? Go to 2 power ith parent. If they are not
Yes.
same, if they are not reaching to that position, please go there. Please go there.
Okay.
Yeah,
Yeah.
understood, bro.
And finally, they will be at one distance apart, which is nothing but this position. I mean, as per the Sam introduced these two nodes, so we will be at this position. So can I say this is my U, this is my V? So LCA is nothing but this
Yes.
only, which is
Mm.
written. What should I written?
U dot dp of u
Uh-huh.
I.
0.
0.
This solves your problem for finding LCA. Okay. Shall we run now?
Yeah, yes, bro.
Or shall we go through code? What do you want? Which one? Okay.
Bro,
Sam.
one doubt.
Yeah, yeah.
Like in the 80 like 80s range, there in that for loop,
Mm-hmm.
like we are checking the when both are not equal. Like
Okay.
in the diagram we have seen there case like it may go out of the range, right? Like I did not get that.
So that's the reason, Sam. What we have done is we have made a one-based indexing. Okay. So in all the values will be zero, right, by default in Java.
Yeah.
So if they go out of the bound, also they will be zero, right, every time.
Okay. Okay.
Yeah, that's the reason I made it one-based.
Okay. Okay.
Bro, can we add a else and can we break the loop?
Where?
Yeah, for 82 if condition.
See,
Can,
we can manipulate it. There won't be any problem. But this is the code which will work for any kind of question. So what we are learning in this sessions are like learning a template kind of stuff, right, every time. So which works
mm,
for all problems, right? So if you learn the binary search check wala thing, it's working for everything. So similarly, we can manipulate here. Whatever you might say, it would work. Okay, but this is the clear code which I have seen till this point. Okay, and what I have learned, I am just teaching you in that way. Okay, there won't be any problem. Cool. Hello.
yeah, 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 yes, bro.
Okay. Yeah. So how many of you understood this code? I mean, like this method. So Deva, are you clear with this, or do you have anything to ask?
Nothing, bro.
Sure, right?
Yeah.
Yeah.
So I'll ask you mock test. This is
Yeah.
okay. So Manan, Sam,
Yeah.
Charlie,
Understood.
whatever you guys like, are you okay? See, we have the comments, so like should be
Hmm.
Yeah. Clear.
Chalo. So I guess everything is done. Now it's all about int queries. while minus we will take two nodes. This method. Okay, so did we initialize everything? Just have a check. Chalo, let's run. Okay, so shall we draw a tree first and then we shall go ahead?
Yes.
Yeah, it's better, bro.
Let's make a little larger. Okay, we shall construct this tree. So how many nodes are there? 12 nodes, so there should be 11 edges. Okay, so 12 nodes. Now it's all about taking the edges. Okay, so someone can remember, I mean 1 2 1 3, 1 2 1 3, 2 4, 2 5, 2 6, right? 5 7 5
Hmm.
8 9, 5 7 5 8 8.
9, 10,
9,
9,
10,
11.
Sorry,
9, 11. 9, 10,
9 10,
9, 11.
11, 12. Shit.
9 10. Okay, 11 12. So how many queries shall we take?
4, 5.
5 queries.
Yeah.
ओके, तो बोलो कौन सा नोट्स का लेते हैं LCA?
4 and 12.
Subs-
So like each one of you start. Okay, so yeah, so 4 and 12.
12.
So let's see, 4 and 12. LCA of 4 and 12 is 2, right? Do we have the answer as 2?
Yes.
Yes.
चलो मनोज भाई आप बोलिए कौन सा दो नोट्स?
212.
212. अच्छा,
Like,
नाइस, ठीक है,
Correct.
चलो
212.
देवा. Okay, you want to see diagram? Yeah, tell me. Which two nodes? Hey, what man? Telling nodes we are taking time. Sam,
Was wait, sorry, 5 and 9.
5 and 9. 5 and 9 ka 5. Is the answer 5, guys?
Yes.
Okay, Sam, go ahead.
10, 11. Yeah.
So let's check with 1 also, okay? Because we missed
Hmm.
1. 1 comma 7,
Hmm.
and we are solving this problem efficiently in log n time. Okay, I mean each query is taking log n, right? So see, what about DFS? DFS is taking somewhere around n log n time, correct?
Hmm.
And each query is taking around log n time, right? Because we are doing that binary jumping and all. So somehow for each query we are able to solve in log n. Okay. So did you see the power of binary lifting now? Like how we are able to solve this in log n. Okay.